Good morning, Tuesday, 25th of November, 2025, 11:15 a.m. Today's skews have come through. They do show a hail signature like yesterday's, but there's a lot less wind shear and there's a very, very strong cap. I believe that if storms form today, I don't think that the surface temperature is going to get high enough to break that cap. I think it's more likely that cooling after sunset will create those storms. Where the storms exist, as I said, there's a hail signature. The wind shear is too low to make giant supercells, but where they do form, they will potentially be intense and have hail. Anyway, have a good day. If you, like me, don't have electricity, hoping you get back soon. Okay, ciao.
Let's examine this morning's 10 a.m. local time atmospheric sounding. On the skew-t diagram, the red line shows temperature and the green line shows dew point. We are starting with 26 degrees Celsius at the surface with a dew point of 22.5 degrees, giving us a very humid air mass with 40 millimeters of precipitable water. Now, notice the surface-based parcel shown by the dotted pink line. Between 934 and 704 hectopascals, there's a strong temperature inversion acting as a lid. This blue shaded area represents convective inhibition or CIN of 108 joules per kilogram, which is currently holding everything down like a pressure cooker lid. Above this cap, we can see the pink shaded area showing the fuel, or CAPE. The surface-based CAPE is 1800 joules per kilogram, while the mixed layer CAPE is 679 joules per kilogram. The mixed layer lifted index is -1 degree Celsius, indicating modest instability. This capped environment is characteristic of morning soundings in subtropical Brisbane. Now let's see the afternoon transformation on the enhanced skew-t. With forecast maximum temperature reaching 34 degrees Celsius, the cap break temperature is 30.8 degrees, giving us a 95% probability the lid will break this afternoon. When that happens, the heated surface parcel gains access to significantly more fuel. Mixed layer CAPE surges to 3398 joules per kilogram, nearly doubling from this morning's value. The lifting condensation level lowers to around 1 kilometer above ground as heating increases the surface temperature, while the level of free convection rises to approximately 1.4 kilometers. The pink shaded CAPE area is now much larger, showing explosive potential once the blue CIN barrier is overcome. Wind shear remains modest at 11.5 meters per second through the 0 to 6 kilometer layer. However, the supercell composite parameter increases to 1.02, which is significant. The significant tornado parameter reaches 0.45, an unusually high value for Brisbane indicating non-zero tornado potential. These parameters, combined with the extreme instability, support short-lived supercells if storms can break the cap. Any storms that do develop will be capable of giant hail, destructive downbursts, and brief rotation. Storm coverage will be isolated due to the strong cap, but intensity will be high. Looking ahead to tomorrow afternoon, the machine learning forecast models paint a more subdued picture. Tomorrow's predicted CAPE drops to 1032 joules per kilogram, with surface-based CAPE at 1551 joules per kilogram. Deep layer shear is forecast at 16.7 meters per second, slightly stronger than today. The lifting condensation level remains around 686 meters above ground, which is more favorable than today's elevated values. However, the supercell composite parameter is only 0.4, and the significant tornado parameter is 0.18, both indicating subsevere conditions. The SHIP index for hail is 2.55, suggesting any storms would have minimal hail potential. The 700 to 500 millibar lapse rate of 5.6 degrees Celsius per kilometer is marginal. Overall, tomorrow's environment supports only isolated non-severe thunderstorms with low threats across all categories. The storm mode is expected to be disorganized multicells at best, with insufficient organization for supercells. The hodograph shows the wind profile through the lowest 12 kilometers of the atmosphere. Surface winds are light from the south-southeast. As we move upward, winds veer and strengthen, with the wind vector tracing a curved path. The colored line transitions from purple near the surface through green and yellow at mid-levels, reaching about 32 meters per second at upper levels. The 0 to 6 kilometer bulk shear is 11.5 meters per second, which is weak for supercell development. Storm relative helicity is 72 meters squared per second squared in the 0 to 1 kilometer layer and 293 in the 0 to 3 kilometer layer, both marginal values. The bunker's right mover star, shown in red, points to the east-northeast, indicating that if supercells were to develop, they would track toward the east-northeast. However, given the modest shear environment, multicellular clusters are more likely than discrete supercells. The atmospheric refractivity profile shows how radio waves propagate through the atmosphere, which correlates with stability layers. The blue line represents the refractivity or N units decreasing with height as expected. Near the surface around 800 meters, we see an elevated duct layer highlighted in orange, where refractivity decreases more rapidly than normal. This elevated duct corresponds to the temperature inversion we saw on the skew-t, confirming the stable layer acting as a cap. The yellow shaded region near 1500 meters indicates where superrefraction conditions exist. This profile is typical of capped environments where a stable layer traps moisture below while drier air resides above. Radio operators may experience enhanced propagation within these ducts, and the profile confirms the atmospheric stratification limiting vertical motion this morning. In summary, this morning's capped atmosphere will likely break this afternoon. Storm coverage will be isolated due to the strong cap, but any storms that do develop will be extremely severe, capable of giant hail and destructive winds. Always consult Bureau of Meteorology official forecasts and warnings for safety decisions. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.